All right, in this example, we're going to look at some power functions, and in particular, we're going to look at the general shape of these power functions and their end behavior. So the first part is asking us to look at x squared, x to the fourth, and x to the sixth. So I've gone out to Desmos and I've graphed this, and I have a picture I'm just going to paste in here. There we go. It looks like I might need to make it a little smaller so it can fit. So there we go. Now I believe that the blue one is x squared, the red one is x to the fourth, and the green one is x to the sixth. But what I want you to notice is the general shape of these functions. They all have this U shape. They all have the same end behavior. They all go through 0, 0 as well. And so in part C and D down here, we're gonna describe the end behavior. But you can see that when you have an even power function, right? You have an even power of x. The end behavior is the same, right? It goes to positive infinity, whether x goes to positive infinity or x goes to negative infinity, right? F of x goes to positive infinity. So next, let's look at the odd power functions. So I'm going to try to, I'm going to try to paste that in here. All right, let's make it a little smaller. And so there we go. Now, again, you can see that these graphs have a very similar shape. Okay, so I think, again, the blue is the x cubed, and the red is x to the fifth, and then the green is x to the seventh. All right, so now you can see that as x goes to positive infinity, the graph is going off to positive infinity, but when we go to negative infinity, x goes to negative infinity, then the graph goes off to negative infinity. All right, so the next part is just to describe the end behavior of these functions, because they have the same end behavior. So all of these power functions where the power is an even integer, right? That we have the limit as x goes to positive infinity of, we'll just say f of x, all right? F of x, where it's a positive, with, f of x is a power function with a positive even power, all right? It looks like it goes to infinity, right? And the same way, we can look at the other end of the domain, and it also goes to infinity, right? All of those even power functions. Now the odd power functions have a little bit different behavior, right? The limit as x goes to infinity of these functions, f of x, we'll just call them f of x. These are the odd power functions. Now, as x goes to positive infinity, the odd power functions go to positive infinity, but when x goes to negative infinity, they go to negative infinity. Okay? All right, so this is going to be important later on. So it's important to know how these power functions behave, because they're going to be important in how polynomials behave and in how rational functions behave. So, all right, I'll meet you in the next video for another example.